At first glance, the Airbus A350 looks like the definition of perfection. Sleek carbon fibre skin, futuristic curves, and that dark cockpit mask that makes it look more like a superhero than a commercial jet. But beneath that smooth exterior lies a machine full of contradictions that changed how engineers think about long-haul flight. How did one aircraft become both an efficiency icon and a design rebel? Why does it have wings that bend like rubber and engines that can shut down from a spilled cup of coffee? The truth is, the A350 wasn't built to look radical. It was built to solve problems nobody realized existed until airplanes started flying higher, faster, and longer than ever before. Every strange feature on this jet hides a story. Some brilliant, some embarrassing, but together they reveal how innovation actually happens in aviation through risks, missteps, and genius engineering that sometimes borders on madness. Today, we're diving into the most fascinating quirks of the Airbus A350, and by the end, you'll never look at a long-haul flight the same way again. That black sunglass mask wrapped around the A350's cockpit isn't there to look futuristic, though it certainly does. It's actually a precision-engineered solution to a thermal nightmare. When curved cockpit glass meets direct sunlight at 38,000 feet, heat builds unevenly across the window surface, creating microscopic stress fractures over time. Airbus's engineers solved the problem with a heat-absorbing black coating that distributes temperature evenly and prevents cracking. The bonus? That same paint improves aerodynamics by smoothing airflow around the nose, cutting drag, and saving fuel mile after mile. It even reduces cockpit glare when pilots fly into a sunrise. Boeing tested a similar concept for the 787 but backed away, afraid passengers would see it as too radical. Airbus went all in, and the decision paid off. The mask became the A350's signature, a perfect blend of science down style and speed. Now imagine cruising calmly over the Atlantic when a pilot's cup of coffee changes everything. And that's not exaggeration, it actually happened. On two separate A350 flights, spilled beverages seeped into the control panels between the pilots and shorted out key electronics, shutting down one engine mid-flight. No disaster occurred, but both aircraft had to divert, flying hundreds of miles on a single engine because of something as simple as a drink spill. The root cause? Cultural design assumptions. Airbus engineers used to tiny European espresso cups, built holders too small for the large mugs American pilots often use. When that oversight met a bit of turbulence, chaos followed. Airbus quickly responded, declaring liquid-free zones, adding protective covers, and updating manuals to prevent future caffeine-related crises. It's funny, but it's also a perfect example of how human habits collide with high-tech systems. The A350 can cross oceans with ease, but it still had to learn how to handle a grande cappuccino. What happens after touchdown might be the A350's most underrated magic trick. Before landing, pilots can choose which taxiway they'd like to exit onto, say a quick turn-off near the gate or one farther down the runway. The aircraft's computer then calculates the precise amount of braking force needed to reach that exact exit and automatically applies it after the wheels touch down. It's called brake to vacate, and it's pure efficiency. The system prevents overbraking, reduces tyre wear, saves minutes of runway occupancy, and keeps airport traffic flowing like clockwork. Multiply those seconds by thousands of flights a year, and airlines save millions in maintenance and fuel. It's the invisible choreography of modern aviation. A 280-ton aircraft slowing itself with perfect timing while the pilots simply guide it home. It's one more reason the A350 feels less like a machine and more like an intelligent partner in the cockpit. If you've ever watched an A350 from a window seat, you might have noticed something unnerving. The wings seem to breathe. They twist, ripple, and flex several meters up or down during flight, almost like a living creature riding the air. This isn't an illusion, it's physics meeting biology. Built from carbon fiber reinforced plastic instead of aluminum, the wings can flex dramatically without cracking or losing strength. When turbulence strikes, they absorb energy instead of transferring it to the fuselage, keeping the cabin smoother and drink steadier. The design also lets the aircraft continuously adjust lift and drag, fine-tuning its performance for maximum efficiency. In other words, the A350 doesn't just fly through the sky, it collaborates with it. That living wing effect isn't just beautiful, it's the reason this jet delivers one of the quietest, calmest rides in aviation history. When Singapore Airlines revived its legendary 19-hour non-stop route from Singapore to New York, many doubted it could work. Previous jets barely made the distance without dumping cargo or stopping halfway. The A350-900 ULR changed everything. With extra fuel capacity, optimized aerodynamics, and lighter composite materials, it could cross 9,500 miles without breaking a sweat. Cabin pressure sits lower, humidity higher, oxygen and levels better. Small tweaks that mean passengers arrive feeling surprisingly human instead of jet-lagged zombies. Pilots rotate in rest bunks. Crew members follow marathon-style duty shifts. Now, the flight is grueling, but it works profitably and reliably. The A350 didn't just break a record, it redrew the map of global travel, proving ultra-long-range routes could finally make business sense and passenger comfort coexist. Inside the cockpit, the A350 feels more like a high-tech workstation than a traditional flight deck. The iconic side-stick controllers free up the center space, revealing something most passengers never imagine. A full-size fold-out desk with a built-in keyboard for data entry and paperwork. It's a workspace designed for pilots who spend half a day at altitude. Add the optional head-up display that projects key flight data directly onto the windscreen, and an airport moving map that activates automatically on landing, and you get one of the most intuitive flight decks ever built. What's remarkable isn't just the technology, but how seamlessly it integrates into the pilot's routines. The A350 proves that smarter design isn't about adding screens. It's about understanding what humans actually need at 38,000 feet. Even the A350's setbacks turned into steps forward. The paint surface dispute between Airbus and Qatar Airways in 2023 led to tougher composite coating standards across the fleet. Engine checks ordered in 2024 after a minor incident helped identify a rare manufacturing flaw long before it became a real threat. Each controversy sharpened the aircraft instead of breaking it. That's the paradox of innovation. Perfection isn't the goal. Progress is. The A350 embodies that mindset, blending beauty with resilience, logic with personality. It's proof that great engineering doesn't eliminate quirks, it refines them until they serve a purpose. The jet doesn't just connect cities, it connects ideas, cultures, and lessons learned through trial, error, and relentless curiosity. If you've made it this far, you already think differently about aviation, and that's exactly what this channel is built for. Every week, we uncover the hidden engineering, design choices, and human stories behind the world's most fascinating machines. If you enjoy learning how technology really works beneath the surface, hit that subscribe button right now, like the video if you discovered something new today, and drop a comment telling us which A350 feature surprised you most. Your feedback fuels future deep dives, and every new subscriber helps us bring even more technically detailed stories straight to you. Let's grow this community of thinkers, tinkerers, and aviation fans because the sky is full of secrets, and we're just getting started.